Alright, so this is the third time I have tried to record this, and it seems like every time I embedded the video of the calculator, then after that all of the sound cut out. So I'm just going to pick up from where I left off with the calculator part. We were talking about how high the calculator can go and what its limitations are. I also want to talk about how low the calculator can go. If you try 0 factorial, you might want to pause the recording and type it in and see if you're surprised at the answer. And then 1 factorial, you can try that as well and see what those numbers are. Those are small factorials. We cannot do any negative numbers with factorials. If you try a negative number in a factorial, you'll get error, so that's not possible either. So there are limitations. Your calculator cannot handle you can't do negatives, and it gets stuck when you do some of the larger numbers. So what do we do with some of the, how do we handle factorials? So what I want to talk about with you is what you can and what you cannot do. So first of all, let's talk about what you would do with 4 factorial over 2 factorial, some of the rules. What you cannot do is you cannot cancel out factorial symbols. Some people might want to go, oh, I want to cancel out the factorial, and then I want to reduce 4 and 2, and I want to tell you that the answer is 2. All right, fake math, completely not true. That is not how factorials work. If you want to reduce a factorial, and you have 4 factorial over 2 factorial, the correct way is to actually write out the definition. Okay, 1, 2, 3, 4, and then the denominator is 1, 2, and then you can reduce. Oh, okay, the 1's reduce, the 2's reduce, I'm left with 3 and 4, and so the answer is actually 12. The answer is not 2, the answer is 12. Some other fake math when it comes to factorials is what to do with parentheses. Now often with parentheses we distribute, and so some people, I want to distribute, and I want to say then this should be 4 factorial minus 2 factorial, and 4 factorial is 1, 2, 3, 4, minus 2 factorial is just 1 and 2. That is 24 minus 2, so the answer must be 22. Again, fake math. Okay, all of that is completely fake. You cannot distribute a factorial symbol. So what you need to do, the correct way to handle that, when you want to do 4 minus 2 factorial, it's actually pretty simple. You just follow, please excuse my dear Aunt Sally. So parentheses first. So 4 minus 2 is just 2 factorial. 2 factorial is 1 times 2, so the answer is 2, not 22. That would be the correct way to do it. So that leads us into some numerical examples where you want to simplify, and the calculator won't be able to do it, but you can. So this is an example of simplify. Could you simplify 100 factorial over 98 factorial? The calculator can't. You will get error overflow, but you can. So by definition, 100 factorial, we'll write out the first 3, 1, 2, 3, dot, dot, dot. Then I'll write out, I know that it ends at 100, and right before that would come a 99, and right before that would come a 98, right before that would come a 97, okay? And the denominator starts with 1, 2, 3, and it ends with 98. And right before that would be a 97, and right before that would be dot, dot, dot. So you can see that the numerator is slightly longer than the denominator. Okay, in fact, here's where they overlap. 1 through 98 is present in both the numerator and the denominator. And because 1 through 98 is present, we can reduce the 1s, the 2s, the 3s. We can reduce all of the dot, dot, dots, the 97, the 98. All we're left with is 99 times 100, which is easy math to do, so we get 9900. So even though your calculator can't do it, you can, not too much difficulty. What about something like 19 factorial over 20 factorial? Okay, well, the numerator would be 1, 2, 3, dot, 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 end with 19, before that 18, before that 17. And the denominator would start with 1, 2, 3, and then end with 20, and before that 19 and 18 and 17 and dot, dot, dot. And again, all of these numbers are going to reduce each other. So 1, 2, 3, 4 up to 19 will reduce those numbers. And when everything reduces, you are left with a 1 in the numerator, not nothing, not a blank. You're left with a 1 and a 20 in the denominator. So the answer is the fraction 1/20th. You can also simplify problems like this. 75 factorial over 72 factorial 3 factorial. So now I've got two numbers in the denominator. In our first two examples, either the numerator or the denominator, one of them was longer than the other. In this one, you're going to see that they're going to be exactly the same in length. So 1, 2, 3, we start out, and then we end with 75. Before that is 74. Before that is 73. Before that is 72. In the denominator, I start with 1, 2, 3. The 72 factorial means I end at 72, and then I have a whole bunch of dots before that. Then I start over with 3 factorial, so then 1, 2, 3. So the overlap is in the first 72 terms. So 1 through 72 will reduce 1 through 72, and I'm left with 73, 74, 75 over 1, 2, 3. That can be reduced. So the 2 can reduce into 74 37 times. And the 3 can reduce into the 75 25 times. So I'm left with 73 times 37 times 25, which is 67,525. So you're going to need to show your work in terms of expanding out the terms and then reducing to see what numbers are left. Those are called simplification problems. Now I want to talk about some notation. There are certain symbols in math which mean that you are supposed to use factorial. One is called NPR. It's written this way. The N and the R are lowercase, the P in the middle is capital. That has a name, which you don't need to know right now. That'll come up in a different lesson. But it does have a formula. And the formula is a fraction. And N is in the numerator as a factorial. Now some people think, oh, R must be in the denominator. Not quite. It's the parentheses and minus R, factorial. And so an example of that might be 100p2. So that would mean that 100 would be in the numerator, and 100 minus 2, the subtraction, would be in the denominator, which is 100 factorial over 98 factorial, which we already did, which turns out to be 9,900. That is the formula for what's called NPR. It's a factorial formula. There's also a formula for NCR. The formula starts out the same, where n is in the numerator, and n minus r in parentheses is in the denominator, but then you have your r factorial. And so this problem has two things in its denominator. And so that would be something where we would maybe see 75 C3. So that would be 75 factorial in the numerator. It would be 75 minus 3 factorial in the denominator, and then 3 factorial, which comes out to be, in simplified form, 75 factorial over 72 factorial 3 factorial, which we just did. And so we saw that came out to be 67,525. So let's do a couple other examples using this. Oh, I know what I meant to show you. There is another way to write that as well. Sometimes they will write it like this, NR. like that. And they use these elongated parentheses. That means the exact same thing as NCR. It's just a different way of writing it, just like we have different ways of writing multiplication. You know, we learned, and when you're really little, you learn 4 times 3, and then you learn 4.3, and then you learn 4 parentheses 3. It all means multiplication, and so this is just two things that mean NCR with factorial. Okay, so let's do some examples. Under this heading, we're asked to simplify. And so under this heading, maybe we're asked to do 37p4. So 37p4 would be 37 factorial over parentheses 37 minus 4 factorial. That would be 37 factorial in the numerator and 33 factorial in the denominator, which means the numerator is going to be longer. And the numerator would be 1, 2, 3, dot, 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 end with 37, 36, 35, 34, 33. And then the denominator would be 1, 2, 3, and it would end with 33. And so the first 33 numbers are going to reduce each other. Okay, 1 through 33 will reduce this 1 through 33, and I'm left with a numerator that's longer. So 34, 35, 36, and 37 all multiplied together, which is 1,585,080. A second example might be something like this. 37 over 4 this way, which means 37c4. And that formula is 37 factorial over 37 minus 4 factorial, and also 4 factorial. These are always equal in length in terms of numerator and denominator. So my numerator is 1, 2, 3, dot, 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 ending with 37, got 36, 35, 34, 33, etc. And the denominator is 1, 2, 3, dot, 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 ending with 33, but then starting over with 1, 2, 3, 4. And so although the first 33 completely reduce, we have some other numbers that might be able to reduce as well. So 2 reduces into 34, leaving you with 17. 3 reduces into 36, leaving me with 12. 4 reduces into 12, leaving me with 3. So I'm left with a 17, a 35, a 3, and a 37. Those things all multiply together to make 66,045. So those are some samples of evaluating and simplifying factorials with actual numbers. The second half of the lesson has to do with factorials applying to variables. Because not only are factorials applicable to numbers, they're also applicable to variables as well. So you can't just rely on your calculator, because variables you can't do on your calculator. You're going to have to know, how do I do factorials with actual numbers? So let's start with a basic factorial with the letter n. What does that look like? Well, we know it starts with 1, 2, 3, dot, 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 and we know that the last number would be the number n. What would come before that would be 1 less. Okay, the number has to go down. So to show that that number goes down, we say parentheses n minus 1. That's 1 less than the number before. And then we go down again, and that would be n minus 2. And the number in front of that would be down again by 1, so n minus 3. So the dot, dot, dots represent all of the infinitely many numbers in the middle, ending with the number n. Well, how does that work if you start with variable n plus 2? Well, it still starts the same. It's 1, 2, 3, dot, dot, dot. But the last number is n plus 2. And so then we have to think about, well, what would be before n plus 2? It needs to be 1 less. So take 1 away. And so that would be n plus 1. And what would be in front of that? Well, we're going to take 1 away again. So that would just be plain n. And then before that, we take 1 away, and that gives me now n minus 1. And the numbers just keep getting smaller and smaller as we work our way backwards. And that's how factorials are written with numbers. So that allows you to evaluate and simplify some other kinds of examples. So perhaps you have n plus 1 factorial over n minus 1. And so you have to have an understanding of what that means. It means that the numerator starts with 1, 2, 3, and the numerator ends with n plus 1. So before that would be 1 less, and before that would be 1 less, dot, dot, dot. The denominator would be 1, 2, 3, dot, 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 and its last number would be n minus 1, which I'm going to write right underneath the other n minus 1. And so I have a complete reducing of these matching terms here. The 1, 2, 3 up to the point of n minus 1 will reduce out the other 1, 2, 3 up to the n minus 1 in the denominator. So that leaves me with just n and n plus 1. This can be distributed because there's no factorial symbol. This is just regular distributing. And so we end up with n squared plus n. And that's the final simplified answer for what we started with. So a couple more examples in working with variables. Example A. I would like to do with you n plus 2 p 2. So let's remember the formula. What that means is n plus 2 is a factorial in the numerator, and it means n plus 2 minus 2 is the denominator, because remember the denominator is the subtraction in parentheses. So that would simplify. The numerator would be n plus 2 factorial. In the denominator, the 2's cancel out, and we would just be left with n factorial. So we're going to have 1, 2, 3, dot, 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 ending with n plus 2. Backing up 1 less would be n plus 1. Backing up 1 less would be n, and etc., all the numbers before that. In the denominator, n factorial is 1, 2, 3, and it ends in n, so I'm going to line that up. And all the numbers in between. And so these first n numbers, 1, 2, 3 up to n, are going to reduce 1, 2, 3 up to n. And I'm left with n plus 1 and n plus 2. Now this is a FOIL problem. First, outside, inside, last. So first is n squared, outside is 2n, inside is 1n, and last is n, for a final answer of n squared plus 3n plus 2. All right, last one under this heading. Okay, what about just n and 2? All right, so remember when it's written that way, it would be nc2, which would mean n factorial over n minus 2 factorial in parentheses, and followed by plain 2 factorial. So let's write out what that would mean. 1, 2, 3, dot, 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 all the way ending with n. Before that would be n minus 1. Before that would be n minus 2. And all the dot, dot, dots in between. In the denominator, n minus 2 here. 1, 2, 3, dot, 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 ending with n minus 2, so it lines up perfectly. But then I start over, And I also have 2 factorial, which means I start over with 1 and 2. So what I've got going on now is a match here between 1, 2, 3 up through n minus 2. So those all reduce each other. And I am left with n minus 1 times n over 2, which is another chance for me to do some distributing. So my final answer is n squared minus n over 2. Now the reason we're working with these factorials is because we're going to be applying factorials to skills over the rest of the week. Today you'll be working completely with factorials on numbers and variables. Then we're going to move on to what kind of math do we use factorials in? We're going to use it for something called binomial expansion, and we'll be using it for some probability and some statistics. And so these factorials are really useful. So I just want you to practice on your worksheet and your book problems working with straight out factorials, and then we'll apply it to some other mathematical topics over the course of the rest of the week. All right, hope you have fun working with these, and thank you for your patience in allowing me to upload a second video.